Hi, Assalamualaikum. My name is Nur Izzati binti Abdul Aziz. I am from class AS1202A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiqah binti Anwar from AS1202A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ayu Shalina binti Isni. And firstly, I will present about the objective of this experiment, which is to measure and determine the acceleration due to gravity G by using a simple pendulum. Next, introduction of this experiment. A pendulum exhibits simple harmonic motion SHM, which allow the measuring of gravitational constant by measuring the period of the pendulum. The period T of a pendulum of length L is given by the formula T equal to 2 pi in square root L over G. Thus, by measuring the period of a pendulum as well as its length, the value of G can be determined by the following formula, which is G equal to 4 pi square L over T square. The experiment was conducted by varying length L of the pendulum. The data collected would be the time period for 10 oscillation T to complete. Then the period T will be determined by using the data T divided by the number of oscillation, which is 10.
Okay, so for the apparatus that we use in this experiment are: first, we use string, second, mass, and third, stopwatch.
Next are the procedures of this experiment. Procedure number 1, a lot and thread with a length of 0.1 meter long has been prepared. Procedure number 2, the mass has been displaced at a small angle. Procedure number 3, the time period for 10 oscillations have been measured with the stopwatch. Procedure number 4, the time period for 10 oscillations have been recorded in the table. Procedure number 5, the time period for 1 oscillation have been calculated and recorded in the table. Procedure number 6, 2 other persons have been repeated the procedure number 1 until number 5. Procedure number 7, the average time for 1 oscillation have been calculated and recorded. Procedure number 8, procedure number 1 until number 7 have been repeated for another length. Next are the results for this experiment. This is the table for the result. For length 0.1 meter, the average time for 1 oscillation is 0.81 seconds. Time power of 2 is 0.66 seconds squared. 0.2 meter, the average time is 0.97 seconds. And time power of 2 is 0.94 seconds squared. 0.3 meter, the average time for 1 oscillation is 1.18 seconds, and time power of 2 is 1.39. 0.4 meter, the average time is 1.36 seconds. Time power of 2, 1.85 seconds squared. 0.5 meter, the average time is 1.48 seconds, and the time power of 2 is 2.19 seconds squared. 0.6 meter, the average time for 1 oscillation is 1.54 seconds. The time power of 2 is 2.37 seconds squared. 0.7 meter, the average time is 1.80 seconds, and the time power of 2, 3.24 seconds squared. 0.8 meter, the average time for 1 oscillation is 1.83 seconds, and and time power of 2 is 3.35 seconds squared. This is the graph of the experiment, t power of 2 against length.
Okay, for the next question is analysis. So, as we know that our objective in this experiment is to measure or to find the acceleration due to the gravity by using simple pendulum, right? So, by using simple pendulum formula here, t is equal to 2 times pi times square root length over gravity. We rearrange it as t squared is equal to 4 pi to the power of 2 over gravity times L. As we can see here, we can interpret this equation as y is equal to mx plus c. This is because because this t squared and L was being plotted into the graph before. As we know, our y-axis from the graph before is t squared and our x-axis is L. So from here, we can find the gravity itself. So here, 4 pi to the power of 2 over gravity is equal to the sum of our m, which is m here in the graph is our gradient. So m is equal to 4 pi to the power of 2 over gravity. From the graph itself, the gradient is 21 over 5. Then we put it together. 21 over 5 is equal to 4 pi to the power of 2 over gravity. Then we find the gravity is equal to, okay, so our G gravity is equal to 9.4 meter per second square.
Next, the discussion. The result obtained from this experiment highlight that the complete oscillation affected by the length of the pendulum. The mass and angle did not affect the oscillation. Based on the graph sketch, the period of oscillation of the pendulum, t power of 2, is directly proportional to the length of the pendulum L. When very length of thread of the pendulum was used in this experiment, the period for obtained oscillation to complete increased as the length increased. Open the graph. The slope calculated from 2 points of the line t power of 2 per L is m equal to 21 over 5. The gradient obtained was then substituted into the equation g equal to 4 pi square L over t square. The equation has been modified as stated in the calculation. The acceleration due to gravity, 4 pi square over slope, g is equal to 9.4 meter per second. In conclusion, the measured value of the gravitational acceleration is not consistent with the theoretical value, which is g equal to 9.8 meter per second due to uncertainty in this experiment.
Okay, lastly, for the conclusion. In this experiment, the conclusion is the acceleration due to gravity g by using a simple pendulum is 9.4 meter per second square.